Alright, so in problem 31, it's believed that as many as 25% of adults over 50 never graduated. We wish to see if the percentage is the same among the 25 to 30 age group. Okay, so how many people, how many of the younger group must we survey in order to estimate the proportion of non-grads within 6% with 90% confidence? And then let's answer that question. So let's see what we got here. Okay, so here's what we got. They gave us a couple things, okay? They gave us that he is 0.25, so they told us that Q must be 0.75, okay? And they told us that they want the proportion of non-grads to within 6%. When they say within 6%, well, within 6% of what? Well, within 6% of p hat. So that 6% is our margin of error. And then they want 90% confidence. So that tells us our confidence level. So when we take apart our confidence interval, this piece right here is our margin of error. So margin of error equals z times the square root of p hat q hat over n, right? So in this case, margin of error is 6%. We're dealing with a 90% confidence interval, and we know that p hat is going to be about 25%, because that's what p is, but we don't know what n is. Okay, so what I always like to do is I always like to divide first, and if I do that, I'm going to get this, okay? And then what I'm going to do is I'm going to get rid of this guy right here. So I'm going to square both sides. Okay, so I'm going to take this answer and I'm going to square it. And I get that. So I really have this 0.00133. And that equals this 0.25 times 0.75 over n. And at this point I make a proportion. So really what I'm going to wind up doing is this whole thing I'm going to cross multiply, right? And then I'm really going to wind up dividing this over here by 0.00133. Okay, so that's what n is going to equal. So I already had the 0.00133, so I'm going to say, okay, 0.25 times 0.75 divided by this answer right here. Okay, and if I do that, I get about 141. So n is about 141 people. Okay, and then question B says, suppose we want to cut the margin of error, suppose we want to cut the margin of error to 4%. So what's the sample size? Alright, well, let's just use our format here. I'm just going to expand this out. But instead of 0.06, we're going to have 0.04. And everything else is going to stay the same. So you got 1.645 times the square root of 0.25 times 0.75 over n. Okay, so what are we going to do? We're going to divide 0.04 by 1.645. Okay, so divide 0.04 divided by 1.645, and I get 0.024. Then remember, we got rid of that, so now we're going to get rid of that. We're going to square that answer. So let's square it, and we get this. Now that answer, don't forget law, don't forget that e to the negative fourth is over here. This is not 5.9, it's 0.00059. Okay, this is scientific notation. That's your way of your calculator doing that. Okay, so I got this 0.00059 equals 0.25 times 0.75 over n. Again, I put that over 1 and now have a proportion. 0.0059 cross multiply times n equals 1 times this. Okay, so I'm going to say, okay, calculator, I'm just going to do this all in one step. 0.25 times 0.75 divided by that answer, and I get about 317. Okay. And generally when we get a decimal answer, just to be conservative, we're probably going to round it up. So we might go up to 317, 318-ish. Okay. And then the last question asks, what sample size would produce a margin of error of 3%? Okay. So, not too much drama here. You're going to do 0.03 equals 1.645 times the square root of 0.25 times 0.75 over n. Divide. So we divided 0.03 divided by 1.645. Right? Then we divided. That's gone. Then we're going to square both sides. So let's square it. Squared. And again, you get 3.33, this e to the negative fourth. So that's really 0.00033. So we got 0.00033 equals 0.25 times 0.75 over n. And what are we going to do? We're going to cross multiply. So this becomes this. 1 times that becomes that. And we're just going to do it all in one step in the calculator. So we're going to say, okay, calculator. 0.25 times 0.75 divided by that answer. We get like 564. Okay, so we'd have this sample like 564 people do not get that margin of error.